We have quite a few people here tonight.
Yes, this group is pretty big. I think I'm going to go ahead and start things. All right, hello everyone. I think Ian's going to miss this meeting as well. So he's asked me to go over the seminar for today. And we'll go over some housekeeping stuff. Then I'll give you a quick talk about sensors in general. And hopefully the idea is we want to get you started talking more about your prototypes and what you're doing. And well, since we're here, ask us questions and we'll do our best to help you out. So I'm gonna start by going through these slides. So just a couple of housekeeping stuff. These seminars, as always, are going to be recorded. You can find a link on edX. And specifically for this one, because I think you'll have access to all 4 sessions. Next week, Ian will be back. So if there are any specific questions you might have had from the course itself, he might answer them in those sessions. So keep an eye on the recording, and also keep in mind that the market research and costing plan assignments are going to be your next step in your projects. Now, congratulations on your on completing your videos. We haven't had time to go through all of them yet. If you've posted them on YouTube, we would have, for the ones you've seen, we would have commented directly on the video itself, in your YouTube comments. Otherwise, for everyone else, you'll be contacted directly. If I'm not mistaken, hopefully we'll be finished marking them by the end of next week. And if you haven't received your mark yet, or if you can see it, you might post a discussion board announcement saying whether the marking is done or not. So keep an eye on that. Let's see. Just as a quick reminder, this is the breakdown of the marks we have for your projects. So most of the assessments have been done. And the main thing I want to kind of get through to you guys is the main difference with this course and some of the other MOOCs that we run and you might have participated is we really want to start getting more direct interaction with you and with the people who are doing this project unit. So you should really start thinking about out of us, who would be the best person to maybe contact more about asking your questions. So just to quickly go over our expertise, I'm CFS, so my main expertise is more on the microcontroller side, sensor side, any choosing sensors, any problem you might have with setting up that physical element of your prototype, Ian and me would be the best people to ask. If you had any questions about AI, we have Hannes. If you had any questions about more mobile app development, or GPS co-location, David would be your guy. Any big data, database, and data analysis, Valerie would be your gal, and of course, Naz would be able to answer more of your networking questions alongside with Ian. So make sure to take a look at the faculty list and the educator list that you have access to on WebEx, and start contacting us and start narrowing down who the best person to kind of start having more conversations with. Ian's gonna finish most of the teaching he is doing, so he's gonna have more free time. We think the next 2 weeks, after the next 2 weeks, he's gonna have more free time. So, in case you needed to set up a one-on-one appointment, we can do that. Now, we are gonna be running the course for 2 extra weeks after the 12 weeks are finished, just to finish up the marking, finish up the feedback we're going to give you, and go over all of the projects. So the MOOC is going to be running for 2 extra weeks. And as I said before, from now on, we don't have that big of a seminar at the beginning of these meetings. The idea is we want you guys to start having a conversation about your prototype. We want you to ask us questions. We'll do our best to answer them, and we want to get the conversation going. So to kind of start on that, I'll start by going through a little introduction thing that I've prepared regarding sensors. All right, so I'm going to give you a very quick overview of sensors, a couple of examples of sensors, talk about a little bit more specifically about IMUs, to give you guys an idea of, especially for if you don't have that technical background, what are the main things you would need to know about your sensors. And because from this week onward, we really want you to start or continue working on your prototypes. If your project is going to be a technical project, and if you don't have that technical background and you're working in more of the finalizing the requirement and specification for your design, you really need to know some of this basic information about the background of the sensors. So some of the projects might end up, some of the concepts are going to be very, very busy. I'm not going to, very basic. I'm not going to go that in depth into them. It's more of an introduction, really. So let's get into them. So basically, the main thing about sensors and microcontrollers is whatever physical characteristic you want to monitor, whether it's, let's say, temperature, pressure, acceleration or angular velocity in terms of accelerometer or gyroscope, and things like that. The case usually is when you connect your sensor to your microcontroller, there is a physical, chemical, or electrical component that you want to calculate. So usually the information we're getting from the sensor itself at the beginning, it's not the actual physical characteristics. So the types of information we get from the sensors, we can just a very broad categorization. We can divide sensors into active sensors, which is your actual sensor wouldn't show you the change in those physical characteristics. It will show you a change in current or voltage. So you calculate that change, you capture that information, you look at the data sheet of that sensor, and you convert that to an actual physical value. Or we can have passive sensors, which can give you a change in resistance, capacitance, or inductance. And then, again, similar to the active ones, you convert that information to actual real-time values. So, as an example of the couple of sensors we have, a very simple one that's pretty useful is an FSR or force-sensitive resistor. What it is, it's a very basic sensor that you can use to kind of capture the pressure of something. I have an example circuit of it here that you can see. It's very easy to hook up. It's just 2 pins. You can just connect to an Arduino, and you're just reading off the pin that sensor is connected to, and you can print that value to the serial monitor. And just to let you know, I'll probably somewhere either in the middle of next week or this weekend, I'll post some of these codes and information that I'm talking about right here, so you'll have access to these source codes. These are just all of the open source code that I use for my own projects here and there. Another sensor that we can have a quick look at is a TMP36. It's a very popular temperature sensor. Again, very easy to hook up. It basically has 3 pins: a voltage pin, a ground pin, and a signal pin. You connect your voltage and ground. You connect your signal pin to one of the GPIO pins on your micro, which is the general purpose input-output pins of your microcontroller. You read out the information that's being sent through that pin, and the equation you see at the bottom, that's for actually converting that temperature to an actual real-time value, because as we said, as it's the case with most sensors, the value you're actually reading is not the actual temperature first. So this is what we mean by raw sensor data. It's the actual change in voltage or current or change in resistance capacitance that we are reading, which gets converted to a real life characteristics. So again, very basic code. You initialize the pin that sensor is connected to. You begin your serial monitor, and these example codes, they just all of the information I'm reading, I'm just passing them to the serial monitor so we can read the information there. So they can see like showing the temperature in Fahrenheit and centigrade. So I know I'm going too fast. If you had questions after I'm done with the slides, I can go back and explain more because I really want to get you guys started, and I want you guys to be talking to us rather than me just talking at you in a traditional lecture sense. So another device. I do apologize for taking breaks because I have a bit of a sore throat, so I'm just drinking some tea in between. Now, another useful sensor, and one of Ian's favorite sensors, are IMUs. What they are, they're basically an accelerometer, magnetometer, and a gyroscope on a single IC, or sometimes divided to two separate ICs with the accelerometer and gyroscope on the same IC, and magnetometer separately. What that does, with the accelerometer, the information we get from the accelerometer, we can kind of convert that to pitch and yaw, so we can get movement, we can capture movement because we are getting information from three different axes. And with the gyroscope, we can get rotation. So because we can get these two interesting characteristics from these IMU sensors, and usually in the case of the project I've been personally involved in, I haven't used magnetometer that much because it's very prone to electrical interference. So sorry, I mean magnetic interference. So we just use accelerometer and gyroscope. And the formula that you're seeing here is how we're actually converting the X, Y, Z's that we have from these sensors to actual angular velocity and movement. So one more interesting thing that we need to keep in mind when we're discussing sensors is the concept of signal conditioning, which is to say, when you capture that raw sensor information, even if you're converting that to a real life value, we usually need to change that signal that's coming into our micro to something else so it's a bit more readable. There are a bunch of different signal conditioning methods that we need to use. Some very basic examples of them are linearization, amplification, and of course filtering. And I have some slides here that you can see what these actually do to the sensors, kind of a before and after we apply these methods to our signals. So here's linearization, amplification to give a bit of a gain to our signal, usually to see it a bit more clearly, and the most important one probably filtering, because in most cases we're going to have noise in our environment, so we need to filter out that noise, or maybe use a low pass filter to kind of remove the bits of the signal that we are not using. So this is what we mean by signal conditioning. Now, as an example of the use cases of these devices, these are two projects that we currently have running at Curtin. One of them, it has these IMU devices connected to a wide cane and leg to build a sort of a wide cane movement training system for people who are visually impaired people. So what they are, it's basically just an Arduino Pro Mini, an MPU 9150, and a Bluetooth module, all kind of sandwiched together. Okay. All right, so that's the device that's capturing the information. And here's a picture of that connected to a wide cane and a leg. This is how we can capture the movement. Another example, something that I'm working on, which is a modified Arduino Pro Mini, which is that green board, and again, MPU 9150, that's the older generation of 9250s, and an RF transmitter. I'm using these to capture the movement, specifically the wrist movement of children with cerebral palsy. I have two of these sensors connected, one to the back of the hand one slightly above the rest. And later on, I'm going to use machine learning to kind of capture this movement and distinguish between given a random captured sample with which where does it fall. So because we have a couple of people working on something similar, I'm going to show you the way that I'm capturing the information in the next slide. And this is, again, these are the prototypes. As you can see, the receiver is literally something that's just sticky taped together, because it's not a product yet. It's just, I'm just working on the proof of concept and just making sure sending the information from the smaller sensors to this receiver, which is just an RF receiver connected to an Arduino, and then I'll just use the serial port reader to read the information. And here's the example of that serial port reader. So what this is just a serial port reader writer. Just a very simple program. I connect my receiver to that, and it starts reading off the serial port. Because that RF transceiver is connected to the Arduino Uno, it captures that information, displays that to the serial monitor. And as you can see, I have a sensor ID because I need to use two of them. So that's how you can distinguish between the two sensors. I have a time, and then I'm capturing the accelerometer and gyroscope information in the 3-axis, and I'm not capturing the magnetometer at all. So one more thing about this specific slide is, as you can see, the values that I'm reading, these are not angular velocity or rotation. These are just raw values that are being read from the pins of the signal itself. Later on, when I capture this information, I feed that to my filtering algorithm on MATLAB and get something like this to have a comparison. So on the left, you can see the movement data captured from a child with cerebral palsy. On the right, movement data from a child who doesn't have cerebral palsy. If you look at the maximum, this is angle versus time. So the maximum angle for the cerebral palsy child is about 25 degrees, and this is, the movement was like a stop sign motion. And the right one, that's just a normal one. So because the child that had cerebral palsy had limited range of motion in his muscles, so that's why you're seeing the smaller degree in the movement. Another example here, this is just from a diagram. This is from a commercial IMU device. We're just doing some tests, which I thought might be interesting to have a look at. It's just one sensor connected to the back of hand, and first slowly moving my hand, then more rapidly moving my hand to kind of find out what's the maximum G that would affect my acceleration. So I can set up my scale. And again, something more slightly slower movement, slower sample rate. And as you can see, you can already see in x-axis and g-axis, x-axis and z-axis, we are already seeing drift. And as we said, the evolution of this prototype, which is something which is now the actual part of my PhD, is I'm getting all of these boards that are being kind of sandwiched together and designing my own PCB, having my microcontroller and the capture, the Bluetooth transfer, and the IMU all on the same PCB, which is going to make it smaller and turn it to an actual product. So I'm going to stop sharing the screen. Let's get to some questions, and we'll go back and I'll show you two different approaches to sensor design. Right, so please feel free to use that raise hand button, and Hannes will unmute you, or if you want, you can type your question in the chat. I encourage you to maybe start, if you've started on your prototypes. I know Sana and Nairi in this group have started working with IMUs. If you wanted to maybe give a quick information. Okay, Sana has raised her hand.
Yes, just unmute Sana. Oh, hang on, I mute. Okay, Sana's unmuted.
Hello, good evening.
Hi, good evening.
I just want to ask you to return the slide. I just want to find out how you can transfer the data from the sensor wirelessly to the PC.
Okay. So with with the prototypes, we have a couple of different ways. First of all, I apologize for answering the email pretty late because I was pretty busy this week. But both Ian and I responded to your email with a couple of links that should help you out with that. But in general, what you probably want another microcontroller with some sort of receiver connected to it, and you can read the information that's coming from it. So I'll show you what I'm doing for my own thing. So this is my receiver. Again, we were prototype for it. This is just an Arduino, and there's just a very small RF receiver connected to it. So what I do is, for my receiver code, I just read any information that's coming from the from the transmitter of my IMU sensor, and I send that to the serial monitor. Okay, so the serial monitor, then using a program like that serial writing that I showed you. Let me go back to the slide. So
because I have very little information about this equipment. Yes.
Have you had a chance to take a look at the links that Ian and I sent?
Yes. Yes, I read about them, but I also have very little knowledge about them.
Okay, so what I'd recommend, like a good place to start with that, don't worry about the IMU part. Just have an RF transmitter connected to one Arduino, or are you using an Arduino as your platform, or is it ESP32?
Yes, Arduino. I already get all the sensor data.
I see. Now I understand.
Yes.
Understand. So now to practice that movement, like the data sending and receiving, don't worry about your IMU. Just connect an RF transmitter, or if you were interested in working with a Bluetooth sensor, there was also a Bluetooth sensor in one of the links that I sent you. Connect that to your micro. Just send a single character through the Bluetooth sensor, and then you also need another Arduino connected to your laptop. Another Bluetooth sensor connected to it. Now, what you're going to end up doing is you send the information from your sender to the sensor that's connected to your laptop, and then you can use this program that I'm using. It's just a free serial port reader writer that you can see on the screen. As soon as you connect your microcontroller to that, it's going to read off the information that's coming in through the wireless channel. Once you get that,
yes.
Okay, go ahead.
Okay. So I need the RF controller, RF sending, right?
Yes. So you need
sensor.
If you want to use infrared, you can use RF transmitter and receiver.
With sensor.
Yes.
And the receiver, Arduino with the PC, right?
Yeah. Yes. And
Bluetooth.
Yes. No. If you wanted to use Bluetooth, you don't need to use an RF at all. You can just use two Bluetooth modules, one to send information from your sensor, one to receive the information from the sensor to the Arduino.
So I need two Bluetooth and two Arduino controller, right?
Yes. The reason I'm saying don't worry about the IMU sensor at first is because it's going to be easier to first get the communication between these two Arduinos working. Once you get that done, then you can implement instead of you sending just a random character to a communication port, you can now send your sensor information to that communication port.
From your point of view, which one is better, Bluetooth or RF communication?
It depends, because if I remember correctly, you were thinking about possibly sending that information to a phone app or to the cloud, right?
No, I just want to the PC so I can analyze the data. I don't want a mobile application.
I wouldn't say whichever one that's more available to you, because if you're sitting close to the sensor, it really shouldn't matter. Both of them should be fairly easy to implement. So I'd say whichever one you can find. The one I showed you that was RF transceiver. The new one I'm working on is using Bluetooth because I wanted to connect that to a phone app, because that was an easier thing to deal with. So and you also have to worry about the bandwidth. But if you just want to kind of see the data itself, you can just do that. If you want to get that wireless communication, I wouldn't say there's a main difference. As long as you're sitting close to the sensor, you should be fine.
Okay. Thank you.
No worries. So we have a question in the chat about the ESPI. Is there a version where I can connect a PIR sensor also run a standalone unit that will be outside? Is it better to have a solar panel or just batteries? So first, about your connecting a PIR sensor, I would say because the ESPI itself is just an ESP32, and it just comes with an extra camera on top of it. I don't see a reason why you wouldn't be able to connect any other extra sensor to it, because it's just a development board. As long as any of the serial communications like I2C or SPI are available, you should be fine. And as far as powering it, it depends on where you're gonna install the device. ESP32s are generally fairly power-hungry devices, so it depends. I would say for your prototype, it's going to be easier to start with just a battery module, and if everything is working as you expect it to, it's working, then you can maybe have a version 2 that implements that solar panel. That's where I would kind of start. Any more questions? I did end up ordering one of those ESP2i camera things. Still waiting for it to get here. And once I had a chance to play around with it, I'll post something on a discussion board. Again, questions. I encourage everyone to talk about, especially if you have questions about the platforms you're using. I'd be interested to see whether you're using an Arduino, ESP32, Raspberry Pi, kind of where you're at with your project, any interesting challenges you've had so far. Well, to kind of get the conversation going, how about I show you 2 more interesting devices. So another approach to kind of building these sort of prototypes is using what we call they're usually sold as sensor tags or sensor development boards. What they are is they're usually a microcontroller with a bunch of sensors connected to them, and they usually offer a phone app alongside that. They end up being a bit expensive, so probably around the $70, $80 range. But the interest, this first one that you're seeing at the moment, this is a simple link sensor tag from Texas Instruments. That was the back, and this is the front of it. It just uses a coin cell battery, and there's a phone app for it. So it has a bunch of sensors on top of it. So if you just wanted to play around with some sensors and see what would be the sort of information you can pass through to a phone app, these would be pretty interesting devices to play around with. Another one that I'm kind of using at the moment is a Nordic 52 thingy. Don't know why embedded system components are so interested in put the thingy in the name, because Spark one has a ESP32 thingy, so the battle of thingies. Anyway, so with this one, again, this has a bunch of sensors on top of it. It has an LED. It also has a speaker, and like here, look at the IMU bit of that sensor. It just uses an MPU9250, captures the information. Sort of like think of it as a more open source Fitbit, which you can get a lot more information from it. Now, why would something like this be useful? The reason for that is they offer the software, software for the phone app, and the schematics for the PCB of the actual sensor as an open source file, then if you wanted to build something like that, especially if you want to get your product to a more actual product after the initial prototype, you'd be able to say, okay, I really like this phone interface that they have for their, let's say, temperature sensor. I'm going to design my own PCB by getting rid of all of the extra sensors that I don't need from their physical hardware, and then I'm going to modify their phone app because I already know it works. So I just modify it so that it's just displaying the temperature sensor information. So that might be something that's useful. Right, so could we have some questions? So Mazin, I like to have assistance in choosing my platform for the ingested sensor for diet control. So Mazin, have you chosen what sort of sensors you're going to be using? So again, what I would recommend is, again, Arduino would always be my first choice as the first prototype because there are so many different types of source code and open source programs and example codes that you can run on them. And especially with your project, since you're just prototyping the idea as a proof of concept, don't actually have the sensor being ingested by someone. So if you have your Arduino, I would say you definitely need some sort of transfer module. Maybe you have to think about what sort of bandwidth you would need when the sensor would be ingested, right? And try to connect those bunch of sensors, those sensors connected to your Arduino, and start reading information from them. That would be the best start, especially because I would hope by now you would have chosen a platform. So just go with something that's cheap and readily available. Connect a bunch of sensors to it, get a bunch of readings, and I think that would be a good start. So, because later on, to be honest, the platform for the prototype, I would always choose something that's cheap and has as many GPIO pins as possible, because then I can connect a bunch of different sort of sensors to it. Then later on, if I wanted to make that an actual product, because I would now actually go and build my own PCB for that product and implement everything on the same board, that's where I can be more specific and more, I guess, stingy with what microcontroller that I'm going to use, what platform I'm going to use. Otherwise, as a prototype, anything that you can find that you have experience with, whether it's a Raspberry Pi, ESP32, or Arduino, all of those would be a good choice. I hope that answers your question. So, all right, so the next one. Anyone else who has, okay.
I believe there's a question about the Bluetooth 5 standards from Vijay Kumar.
Okay, so Bluetooth 5 standard. I personally haven't played around with Bluetooth that much because what I've been using at the moment it was just an HC. So let me find the module. I post a link for it on in the chat. So what's it? HC Bluetooth module. Let me see which. Right, so this one. Let me share the screen so everyone else can see as well. All right. So these HC05 and HC06, these are fairly popular Bluetooth modules. I think the newest one does support Bluetooth 5. And find which one it supports at the moment. But the reason I'm bringing this up, I'll post the link in the chat in a second, because with Core Electronics, it's an Australian reseller, but I'm not putting it here so you to be encouraged to buy from them. It's just that they usually include lots of information in their product page about how you can communicate and lots of tutorials here, how to communicate and how to work with sort of a Bluetooth transfer. And this is actually something that might help Sana as well. So I'm going to post the link. So if you see, if you scroll down here, you have all of these guides and videos and these tutorial modules in how to implement them, and a couple of even source code and how you would send and receive information with them. So this might be what you're looking for. I'm gonna post it in the chat. So Mazin asks, okay, do I use micro Arduino? It doesn't really matter. I would probably say it depends on how many sensors. So Mazin asks how many, like whether he should use a micro Arduino or mini Arduino or which one. I would say the main difference at this stage would be the number of input-output pins you'd have access to. That would be your main difference between, let's say, choosing a Uno versus a Mini or a Pro Mini. I would say whichever one you can find, whichever the cheapest one you can find. Probably if you go with an Uno, you have access to more pins, so you can test more sensors at the same time. Otherwise, if you have a smaller number of sensors, the Uno would be fine. A Nano would be fine. I'd like to have an assistant shooting. So we talked about that. All right. So how about I show you a little bit about AWS. So I just switched my screen. Hannes, can you see my AWS screen here?
I can, yes, the management console.
Right, yes. So, because we had a couple of people asked me about cloud computing. So I just had attended a 3-day kind of workshop with AWS. So the only thing I would say, so with AWS, this is after you sign up for an account with Amazon and you get access to their console. You see on a screen like this, and they have this section, connect an IoT device, and when you click on that, it takes you to a bunch of tutorials, and you can choose between what sort of platform you have, how do you want to send the information to the cloud, and it gets a bit more complicated from here onward because they have two separate kind of training systems for you to learn the tools. They have a Amazon Training and they have Amazon Educate. So these two separate portals over here, which you can sign up. The sign up for them is free, and they have a bunch of tutorials and videos of how you can kind of utilize cloud. I would say, especially someone like me who has from an engineering background, you do need to have a bit of networking and IT knowledge to kind of work with this platform. And I would say be a bit careful about using this because the pricing that they have for using their services is very flexible. The model is a pay as you go, so pay as you use. That's one of the most popular models of the payments that they have. The problem with that is if you, let's say you're creating a system and you're running your code on it, if you forget to stop that, the amount of space it's using and the amount of computation power you're using is might gonna add up in cost, especially even for a free account, you still need to put in your credit card information. So be a bit more careful about using cloud similar services like that. All right, so Sana asked, I'm using an HTM10. Let me see. Can your LoRa be used to send images? Let me just first look for the HTM10. I'll get 4LE. So to answer your question, Sana, I don't see a reason of changing what you're using at the moment. What you're using should be fine. That works as well. The only reason I showed that HC10, that was just an example, so that should be fine. And using LoRa to send images, again, that's more of a networking. I don't know how big of a bandwidth LoRa would have. But in terms of working with LoRa and microcontroller and platforms, I'd recommend this thing that we've kind of played around with. This is called a Dragino kit. This is a LoRa shield for your Arduino, and it has a bunch of sensors. It has a GPS and a temperature sensor, and I think a humidity sensor, and it works with a LoRa module. So that might be an interesting device to play around with. Another one, so I posted the link for that on the chat. Another one that could be interesting are these ESP32 LoRa modules. So ESP32s are fairly popular these days because the main reason for that is because they have a wireless and a Bluetooth module embedded on the microcontroller, so you don't have to deal with kind of connecting a separate module to your micro. So that's why they're popular. And as Ahmed says here, it says LoRa is low bandwidth, so you really shouldn't be using it to send images. So yeah. So you wanted for the 3-day workshop thing. So that was for an educator workshop, but the name of the course itself, let me see, because I don't know if you can attend it as a, let me see, Amazon Cloud Foundation. If you are a university student, you might have access to it, but so you would find that here in their training website, and the course you're looking for was called AWS Cloud Foundation course, something like this. So yeah, take a look at that. See if you might find that. But you can find similar stuff in their Educate portal. Again, it's weird because they have Amazon Training and Amazon Educate, and with Educate, some of the free tiers will actually give you some credits that you can use in their AWS server. So I think with the free version, if you're part of a university, you get like $70. So that might be an interesting way to kind of take a look at their courses. Some more questions. Is this course provides which information do you recommend? Well, I would say if you're really interested in more of the networking aspect of IoT, definitely it has some interesting information in it. But the foundation course, I would say the main problem of it was very, they were kind of trying to sell their platform a lot. So and then you have to take an exam for it, and the exam is gonna have us memorize the name of all of the different storages and the different pricing modules and things like that. So I wouldn't say the foundation course probably, unless you're interested in kind of getting really serious with working with clouds, because then it has a couple of different tiers. After you do the course, then you can get a certificate for it, then you can do some of the more development focused course of it, which they help you kind of work with the device, which work more with the platform. So I would say it's definitely worth looking into. But they have lots of like if you're interested more specifically with using the cloud as a part of your IoT, check out their Educate website. They have a lot of free training, so that might be interesting. So we have a couple of questions coming in.
Ahmed had his hand up.
Oh, all right.
Dealt with.
All right.
Are you okay?
Ahmed, yeah, go ahead, Ahmed.
Ahmed, please do get back to us if you do have a question still.
Sure. What is the best library for processing images to identify people on a Raspberry Pi? Libraries. I haven't used libraries specifically on the Raspberry Pi, but Hannes, do you know of any image processing of libraries on smaller devices?
No. That said, there are a lot of libraries available for both Python and various flavors of C, and both of those can be used for the Pi.
Mm-hmm.
So it really depends what sort of processing you want to be doing.
Mm-hmm.
Each of those, has, especially Python, has huge amounts of libraries.
Yeah, definitely check those out. If you needed more information about that, I encourage you to send us an email with that topic and possibly put Ian and Naz's name in the tags because they might have a bit more information. There might be a specific library that they can suggest. And so, all right, another question from Madison. At the start of this session, I had a quick glance in one slide mentioning that the student has to think about specific advice to follow up with this project. Am I right on what I understood? Yes. So it doesn't mean that you can only take advantage of one advisor, but it was just there to just make sure that you know who would be probably the best person to have to be more in contact with, and encourage you to kind of contact us and let us know if you have questions. So we have James raised his hand. Hannes, would you mind unmuting him?
Evening, Suresh. Can you hear me?
Evening. Yes, go ahead, please.
Okay, Suresh, thanks. So I've just got a question just in terms of what we've been discussing in the sensors and the data, etc. For the final project, I haven't really seen a template yet just in terms of what that should look like, the final project. Should we be, I want to prepare my thinking in terms of, do we need to collect data for the final project? If we haven't got a prototype up and running, what sort of information should we be thinking about for that final report?
So as we move along, we definitely give you more information of what exactly we are looking for. But as a general note of it, if your project is technical and you have a prototype, you talk about your prototype. But if you don't have a prototype, which you don't have to have a working prototype, then your project is going to end up being more you specifying what are this. Let's say for one of the projects, let's say for Mazin's project, we wanted to get the inside of a stomach information for obese people. So with something like that, then if we were to just specify that project, you would look into, okay, this would be a suitable platform. You talk about the platform, you talk about the different sensors that you can use. You talk about the specification for those sensors. What are the requirements you would have? What are the constraints you'd have for implementing that sort of a project? So then it's going to end up being you doing more research about what are the things you have to keep in mind, and then researching on those. And if you still needed more information or a more specific template, I'll ask Ian and post something on the discussion board, or he might have something ready in the next time we're having these seminars to show you an example of what we're looking for. So that answers your questions a bit.
That's great. Thank you very much, Suresh.
No worries. So we have 5 more minutes. We're starting to wrap up. If there's any... Okay, no worries, no worries. So anyone else, any questions? We have 5 more minutes. And again, Ian will be back next time we are running the seminars. And make sure to contact us through email. Make sure to put in the name of the supervisor you wanted to talk to. laptops. If we don't get back to you within 2 weeks, please send us an email again. Sanat asks about commercial IoT platforms such as Thingsboard or other fruit. So those would work as well, Sana. I think especially with Thingsboard, it does have a couple of options. But I would say specifically with your project, since you already started on a prototype, I think it would be more interesting to kind of see where you can take that. But we can have a more of a discussion through email. If you send us another email once you had that communication going, what kind of simulation can be used for business-oriented project? I think the Thinkboard and other fruit would be good options for business-focused and business-oriented projects as well. Again, with those more simulation-type questions, Ian would probably be the best person to ask. So again, I'd encourage you to send us an email about that. And if I can find something a bit more firm for that question, I'll post some links on the discussion boards. I'll try to be a bit more active because I've just gotten access to them as educator. So I'll start posting information, some links, some sensor source scores and things like that. So hopefully that can be good. So if anyone else doesn't have any questions,
Ahmed has raised his hand again.
All right, Ahmed, do you want to go ahead? Can't hear you, unfortunately. If you want, you can type your question in the chat. Okay, sure, no problem. All right, I think that's it for us. Hope everyone have a good rest of the day. I encountered some difficulty and slow development, the prototyping issue. Is that okay? Yes, that should be fine. So if you just had more questions, send us an email. Ian will be back tomorrow, so you should be able to answer more of your questions a bit more quickly. Right? Again, thank you, everyone. I'll post some of the links. I did post a couple of links to the chat, so you can go through that. Click on some of those, and I'll post some of them on the discussion board, so you'll have a more direct access to them. Again, like Core Electronics or SparkFun are good websites to have an eye on for getting source code information. So. Right?
Thanks, guys.
No worries. Thank you. Good luck with your projects, and hope to hear more from you guys soon.
I will.